Hello students, welcome to Educate. Today we are going to continue with question number 13 onwards of chapter Gravitation of class 11th physics. So question number 13 says, how will you weigh the sun? That is, estimate its mass. The mean orbital radius of Earth around the sun is 1.5 into 10 power 8 kilometer. So, if you remember the formula, m is given by 4 pi square divided by g times r cube divided by t square. Origin of formula we have already discussed. If you wish, I can tell you once again that it is derived from the concept that this is mass m, this is small m, so there is centripetal force in this direction, it is moving in this direction with velocity v. So you can say g times mm divided by r square is equal to mv square divided by r. One r will cancel out, one m will cancel out, and v equal to 2 pi r by t. So gm divided by r into v is 2 pi r, so equal to 4 pi square r square divided by t square. Now your concern is to get m, so g will go in denominator, so you will get 4 pi square upon g times r cube divided by t square will be equal to m. So that is the basic of the formula. So writing the formula once again, m equal to 4 pi square divided by capital G, then r cube divided by t square. Here we have sufficient information to evaluate. 4 pi square, 4 into 9.8, 3.14 square is almost 9.8 divided by value of G, 6.67 into 10 to the power minus 11 times. Mean distance that is given this same thing 1.5 into 10 power 8. So 1.5 into 10 to the power 11, it is in meter, then whole cube divided by time period. So time period is 20, so time period will be 365 days. So 365, 24 hours into 60 into 60 whole square. Now let's write the digits. 4 into 9.8 into 1.5 into 1.5, right? Then 3 times 1.5 multiplied by 10 to the power. Here 11, 3 times 33, and from here this minus 11 will go in numerator, so it will go plus 11, and then in the denominator the digits are 6.67 into 365 into 24 into 60 into 60. Now you can use calculator or you can give time. So if you evaluate it, it will come out to be 2 into 10 to the power, this is 2 into 10 to the power 30 kg. So I think you can do. Here only the difficult thing is just calculation. So for that purpose you can cancel 2 zeros at least from there, and then you can cancel others, you can remove decimal, etc., so that you know how to calculate such questions. Next question is question number 14. A Saturn year is 29.5 times the Earth's year. How far is the Saturn from the Sun if the Earth is this much kilometer from the Sun? So here Kepler's third law of planetary motion, T square proportional to R cube. Saturn year is this much times that of Earth. How far is the Saturn from the Sun? This. Okay. So T Saturn square divided by T Earth square equal to R Saturn cube divided by R Earth cube. Right. And we have to find out this. How far is the Saturn from the Sun? So RS is to be found. So do one thing, take RS, keep RS here and then you can shift it. So RS cube equals TS upon TE whole square multiplied by RE whole cube, right? And if you take cube root, what do you get? RS equal to TS upon TE whole power 2 by 3 into RE. Now you can put the values. So here Saturn year is 29.5 times that of Earth's year. So do one thing. There you can write 29.5 TE and then they will get cancelled. Only 29.5 will be left. So RS equal to 29.5 whole power 2 by 3 into RE. In place of RE, you can write this value 1.5 into 10 to the power 11 meter. You can write it in kilometer also and try to simplify. Here you have to use calculator. So think and try to do. It will come out to be 1.4 into 10 to the power 12 meters. Now, consider next question. What is next question? It says a body weighs 63 Newton on the surface of Earth. What is the gravitational force on it due to Earth at height equal to half the radius of Earth? So here value of G at height. G at height is given by G times R upon R plus H whole square. So let's find out its value. So G times R upon R plus, they are saying that equal to half the radius. So R by 2 whole square. Simplify G into, this will become 2R plus R, 3R. So 2R by 3R whole square, that is G times 4 upon 9. Now, if you multiply the relation, you have got GH equal to G times 4 upon 9. So, if you convert into weight, so mgh is equal to mg into 4 by 9. But in our question, mg is given as 63. So, it will become 63 into 4 by 9. 7 times. It will be 28 Newton. So, you have solved question number 15. Now, let's consider next question. Next question is question number 16. What does it say? It says, assuming the Earth to be a sphere of uniform mass density, how much would a body weigh halfway down to the center of Earth if it weighs 250 Newton on the surface? So again, you have to find out the value of G at depth. G depth is given by G 1 minus D upon R. Here they are saying that halfway down, so take r by 2 as d, then what will happen? So gd will be equal to g times 1 minus 1 by 2, that is g into 1 by 2. If you convert it into weight, so multiply by m, mgd is equal to mg into half, but in our question mg is given, mg is as 250 newton, so just write 250 newton, so 250 multiplied by 1 by 2, that is 125 newton. Question is clear? Let's go to next question. A rocket is fired vertically with a speed of 5 km per second from the Earth's surface. How far from the Earth does the rocket go before returning to the Earth? Mass of Earth is this much, mean radius of Earth is this much, g is this much. So here you can apply the concept of energy conservation. So what happens? Situation is like this. Suppose we take this Earth, suppose rocket is here, and now it goes up to height h. At this point, what is situation? At this point, what is situation? So what is potential energy here? So total energy at this point will be potential energy plus v velocity is given, so it will have kinetic energy also. So you can write it minus gmm divided by radius of Earth plus half mv square. So this is energy at this point. And at this point what happens? There is no kinetic energy, but potential energy will be there. So this must be equal to minus gmm divided by r plus h. Now we have to find out the value of h. So just simplify. So at least m will get cancelled. And let's write v square term in LHS and other terms in RHS. So it will become v square 1 by 2 v square equal to minus gm divided by r plus h plus this will become gm upon r. Now if we multiply by 2 to each term, v square equals minus 2 gm upon r plus h plus 2 gm upon r. Our concern is to get r plus h. So let's proceed. What can be the next step? So we take this term to LHS. 2 gm divided by r plus h equal to 2 gm divided by r minus v square. Further, 2 gm divided by r plus h equal to 2 gm divided by r minus v square r, or this is v square r means we have taken it common, so let's write it like this: 2 gm minus v square r divided by r. Now it is little easier, so let's invert it. So r plus h divided by 2 gm equal to r divided by 2 gm minus v square r, or r plus h will be how much? R plus h equal to 2 gm r divided by 2 gm minus v square r. Now evaluate it by putting the values. M is given So here mass of Earth is given 6 into 10 power 24. So in place of this you will write that. Value of G, you know, 6.67 into 10 power minus 11. And mean radius is given this much. And then whatever value you get, from that value you have to subtract radius of Earth. So H will be the value so obtained, suppose this is X, minus R. It is a little complicated, just a calculation is involved, you can do. The answer to this question will be (1.6 into 10 to the power 6 meter). So you can get it. Next question. Here, in previous question, also one thing, the velocity is 5 kilometer per second. So you have to write it as 5000 meter per second because other quantities have been taken in SI unit. Correct? Be careful. The escape speed of projectile on Earth's surface this much, a body projected out with a thrice this is speed. What is the speed of the body far away from the Earth? Ignore the presence of the sun and the planet. So suppose after escaping, velocity is VO. Present velocity is V and escape velocity is VE, right? So what happens? You can say in terms of kinetic energy, half m VO square must be equal to half m V present square minus half m VE square. So what is happening here? So half m will cancel out. So VO square is equal to, this is in our question it is the escape speed of this much, a body projected with thrice this speed. So this is triple up. So 3 means 9 VE square minus VE square, right? So it will become 8 VE square, that is VO square. So VO will be 2 root 2 times VE and the VE is 11.2. So 2 root 2 multiplied by 11.2 and you can evaluate it kilometer per second. Question is simple. Now let's go to question number 19. A satellite orbits the Earth at a height of 400 km above the surface. How much energy must be expended to rocket the satellite out of Earth's gravitational influence? Mass of satellite is given, mass of Earth is given, radius of Earth is given. So here you have to find out what energy the satellite has and whatever energy it will have, that will be negative. So equal to that value, positive value, you have to expend so that total energy may become 0. So here our concern is to get energy. So energy conservation, not energy conservation, just energy calculation should be done. So suppose satellite is here, right? A satellite orbits the Earth at a height of 400 km. The radius of Earth, this is R, this is 400 given kilometer and satellite is here. So how much energy must, so other information, mass of satellite is also given 200 kg. So we can find energy. So at this point, what is energy? And one more thing, since it is moving, so it will have kinetic energy with equal to, which will be orbital velocity VO, and VO will be, sorry, not 2, just gm upon r plus h, right? So total energy, if we write total energy at that point, so 1 by 2 m VO square minus, not minus, but since potential energy we are going to calculate, it will be minus. So it will be G M M, mass of satellite is M, mass of Earth is capital M, divided by R plus H. Let's see what you are getting from here. 1 by 2 M and VO, just square it, so you will get Gm divided by R plus H minus Gmm divided by R plus H. So this will give minus 1 by 2 Gmm divided by R plus H. So this is total energy. Now put the values. Information is given. So minus 1 by 2 into 6.67 into 10 to the power minus 11 into mass of Earth is given as 6.4 into 10 to the power, 6.0 into 10 to the power 24. So GMM into mass of satellite is 200 whole divided by 2 is already R plus H. Radius of Earth should be given 6.4 into 10 to the power 6 plus 400. So here, with respect to this value, 400 is negligibly small, so you can ignore and just evaluate it. Take 1 minute. So it will come out to be minus 5.89 into 10 to the power. It will be how much? It will be 9. It will be 10 to the power 9 joule. Right? So this question is also clear. Now let's consider next question. Two stars each of one solar mass 2 into 10 power 30 kg are approaching each other for a head-on collision. When they are at a distance of 10 power 9 km, their speeds are negligible. What is the speed with which they collide? The radius of each star is 10 power 4 km. Assume the stars to remain undistorted until they collide. Use the known values of G. So here situation is simple. One star here, another star here. So we can calculate potential energy, and when they collide, they will touch each other. So here we will find separation. Here separation is given. Radius of the two are given. So here again there will be potential energy PE plus KE. Here only PE. Then we can apply energy conservation principle. So let's see how we can do. So what happens? Potential energy in the beginning, so PE, let's write it initial, will be minus GMM, both will be M, divided by R. What is separation in the beginning? Separation in the beginning is when they are at distance 10 power 9 kilometers. So let's write it 10 power 12 meter. Now when they touch each other, then what happens? Then potential energy plus kinetic energy both will be there. And since since two stars are there, both will have same kinetic energy. So let's write it half mv square for both. right? This will be total energy then. So potential energy in that case, separation will be left how much when they touch each other? So 10 power 4 means one is this, another is this, right? They are touching, so radius of the two separation will be equal to 10 power 6, 10 power 7 meter, 10 power 7 meters. So 2 into 10 power 7 meter will be the separation. Now, so you can write minus GMM divided by 2 into 10 to the power 7 and plus here not half, it should be 2 because half kinetic energy, half mv square. There are two stars, so just double it. So 2 will cancel out. Then m times v square. Right. Now you can equate the two. So what do you get? You will get minus GMM divided by 10 to the power 12 must be equal to minus GMM divided by 2 into 10 to the power 7 plus m times v square. Up to here any problem? I don't think so. M can be cancelled and then we can put the values. So after putting the values, we can get V. Here G equal to 6.67 into 10 power minus 11 and mass is given as 6. We are taking this. So mass of the two stars is 2 into 10 power 30. So we can put the values and then we can get the answer. Even if you write here both masses are same, gm square, so 1 m will also be there here also, so that will get cancelled. So it does not matter whether you write small m or capital M. That is understood. Now what would the final answer be? Think, give 1 minute. So final answer you will get 2.6 into 10 to the power 6 meter per second. And let's see last question. Two heavy spheres each of mass 100 kg and a radius 0.1 meter are placed 1 meter apart on a horizontal table. What is the gravitational force and potential at the midpoint of the line joining the center of the sphere? Is an object placed at that point in equilibrium? If so, is the equilibrium stable or unstable? Question simple. Here, this is one sphere, this is another sphere, and we have to find out gravitational force and potential at the midpoint. Suppose here at the midpoint there is mass m, say this is capital M, this is capital M, this distance is x, this distance will also be x because this is midpoint. So force will be equal and opposite. So at this point the two forces will cancel out each other. So there will be no force because direction of force for this, if you take in this direction, for this you have to take in this direction, and magnitude will be same because distance is same, product of mass is same, so force will be 0. Now as far as potential is concerned, so potential due to any one and then double it because it is a scalar quantity, so value of potential due to this at this point and due to this at this will be same. So you can say potential will be double of, so just write minus sign, minus twice of Gm divided by R, right? And minus 2G 6.67 into 10 power minus 11 into mass is given as 100 kg and separation will be half of that value, so 0.5. So just simplify. minus 2.7 into 10 power, how much? Minus 8 joule per kg. Minus 8 joule per kg. Now, next question is, if you place any object at the center, then the object will be whether in equilibrium. If yes, then will it be stable or unstable? So here, suppose you place something here, that force in this direction, force in this direction will be same. But to check whether the equilibrium it's in equilibrium, that is okay. But stable or unstable, if you want to check, so just give a push to this object. Suppose it moves here. So will it come back to original position? No, because in this direction force will be more, so it will be attracted by that. So if such a situation is there, then we say the equilibrium is unstable, right? So here, or if you push the object in this direction, so it will move in this direction only, it will not come back. Since it is not coming back, it means equilibrium is unstable. So this is how your first book is over. From next lecture, we will start second book. Thank you for watching. Team Educate